happening here is things are being multiplied together. So the big thing I have to do is a product rule. Now product rule, we do one derivative at a time. So here are my two things being multiplied. So derivative of the first. What's the derivative of that first one?
W minus t.
Times the second plus the first one times derivative of the second. What would I have to do the derivative of that one? Change it. So exponent comes down, inside stays the same. Subtract 1 from the power, so it's now to the 4, times, since it's not just a single variable on the inside, derivative of the inside is 1. At the very least, I expect you, to multiply 5 times 1 is 5, and if you would, at least pull the coefficient to the front of that term. There's more you could do. You could take out a w plus 4 to the 4th and multiply and combine some like terms from there, but this is bare minimum on what I expect with your simplification. Are we remembering this from last week? Hopefully. We've done a lot of them at this point. Okay. Let's do this one twice. Once with and without the chain rule. Chain rule is just another form. If I were going to do the chain rule, there would be no need to multiply it out first. So the chain rule basically saves you some work up front. You don't have to multiply that out. So if I did my derivative of that, what would it be?
3 times 1 minus x squared times negative.
So we get negative 3 times 1 minus x squared. Without the chain rule, it takes more upfront work to do it without. Without, you would have to first multiply this out, which I did for you. Then the derivative is easier. So it's basically a toss-up. Do you want to do more work at the beginning or at the end? If I did this derivative, we get
Negative 3x squared plus 6x minus 3.
And you didn't have to put it in that order. You could have done negative 3 plus 6x minus 3x squared. Order doesn't matter. So we get the same derivative. These things are equivalent if you multiply this first one out. We get negative 3 plus 6x minus 3x squared, which is the same. Okay, so just reiterating what we talked about at the very beginning. Chain rule is not giving us a different answer. It's just an equivalent answer. If I ask you to do a derivative, I'm never going to say you must do the chain rule or you must do the power rule. You do the derivative however it works for you. So if you would rather cube that first and do the derivative, that's totally fine. There are situations where we can't avoid the chain rule, but in the cases where you can, it is up to you how you would like to solve it. All right, last one for today. This one is ugly. Is there any way to avoid my chain rule? No. Okay. We start on the outside. So that's the negative 5th power. So derivative of the outside, the negative 5 comes down. The whole inside stays the same. subtract 1 from the power, so it's now negative 6. Are we done? No, we don't have just a plain x on the inside. So we keep going. So now we're focused on the derivative of the inside. So to do that, the derivative of x is 1 plus. How would I do the derivative of this expression?
Distribute.
Well, it's an exponent. I can't distribute it to each of them because there's only one term. What would I have to do to get
Or
that?
you just get the inside derivative.
Okay.
Wait, so it would just be parentheses, 1 plus.
Let's pull this away from everything else. If I told you to do the derivative of that, what would you do? Chain rule. -3, inside stays the same. Subtract 1 from the power times derivative of the inside is
2x.
So that's what we're doing. We have to do the chain rule within the chain rule. So the exponent comes down, inside stays the same. Subtract 1 from the power, so it's now to the -4 times derivative of the inside. So derivative of x plus x squared would be 1 plus 2. Was this pretty? Not at all. There's some simplifying you could do, but very minimal. At best, you could take your -3 times the 1 plus 2x. It's not really going to gain us a lot. This one's just ugly. But I just want to show you, you have to keep doing the chain rule if you still have a function within a function. Sometimes it might require multiple chain rules to get to the answer. All right. Questions? So I'm going to give you a handout and I'm going to take